Good morning, boys and girls. I'm going to go over some problems in today's math packet, some examples for this first couple of pages. You'll see on the first page of week 2, there are some word problems. They're not your typical word problems, they're more like logic or puzzle solving. So the first one says, I am a 2-digit number. The sum of my digits is 10. The tens and ones digits are odd. The tens digit is greater than the ones digit. What number can I be? Okay, so first thing is I've got the question here, can I be, makes me think that there might be more than one answer. Okay, then I'm going to go back and read this closely. I am a 2-digit number. Okay, so I need 2 digits. So it's somewhere between 10 and 99. The sum. What does the word sum mean? Sum means addition, right? So the sum of my digits, so these two, whatever these two numbers are, when I add them together, they're going to equal 10. Okay, well, I've only got so many things that can equal 10, right? So when I add, like for example, 1 and 9 together, that equals 10. Okay, so the digits could be 1 and 9. When I add 2 and 8 together, that equals 10. Oh, except for it says the digits are odd. Okay, so it's not going to be 2 and 8. So I can make a list. 1 and 9, 2 and 8 is not going to work. 3 and 7 could work. 4 and 6 aren't going to work. But I could do 5 and 5, I guess, right? It doesn't say the digits have to be different, I don't believe. The sum of my digits is 10. Oh, except for the tens digit is larger than the ones digit. Well, if I did 5 and 5, that's not going to work, is it? Okay, so I really have two options here. I have 1 and 9 and 3 and 7. Okay, so if I choose one of those, I just have to make sure I write the number correctly so that the tens digit is greater than the ones digit. Okay, so basically I could choose 91 or I could choose 73. Either one of those would work. Okay, so that's how you're going to do these types of problems. I think there's 4 more that you can work on. Okay, down here you're going to write an expanded form, which we talked about on one of the other videos, where you're taking this and dividing it into a addition problem. For example, 3,000 plus something. Here we've just got some basic math. And on the back side, we did cross out some things on the bottom, but this looks like it's mostly rounding to the nearest 10 and 100, rounding to the nearest 100 and nearest 10. So again, these numbers are not very complicated. There's no decimals involved. So I'm going to just remind you again, when you're rounding, if the number is, for example, 394, and I'm rounding to the hundreds place, I'm looking at this number 9, the one next to the hundreds place, to decide if this number is closer to 10 than it is to 0. 5 or more, raise the score. 4 or less, let it rest. If it's larger than, if it's 5 or more, it's going to make that 3 round up, that 300 round up to 400. These all digits have to become zeros when I round. Okay? If I have a number that is something like 917, okay, and I'm rounding to the hundreds place, I look at the 1. That tells me the 9 is going to stay the same because 10 or 17 is closer to 0 than it is to 100, right? So I'm going to make that 917 900, okay? On one part of the sheet, they ask you to do both. So 567, they round to the tens place and the hundreds place. So first I would look at this number with the 6. I'd look at the 7 and say, oh, that's going to round up to 570. Okay, then I'm sorry. Then I'm going to look at the hundreds place and look at the 6 and say, oh, that 6 is going to make that 500 round up to 600. So I'm going to have 2 answers on these ones. So let's try another one, 728. Okay, so first I look at the 2 and I look at the 8 after it. So this is a 2, which actually represents 20, right? So I'm looking at the 20, I'm looking at the number next to it. Oh, that's 28. Of course, that's going to be closer to 30, so it's 730. And then if I take that same number and look at the hundreds place, and I look at the 2 is telling me that that's going to stay a 700 because 728, the 28 is obviously closer to 700 than it is to 800. So those are my numbers. And again, these are much simpler than some of the ones that we had done with decimals. So you'll be seeing some decimal work a little bit later. Okay, and then we have questions like even and odd, and I think you can manage those ones. Okay, on the next page, you're just adding and subtracting, which I know is not difficult for you, but that's where we make careless mistakes sometimes because we aren't always careful about our work when we think it's simple. Okay, then we have a page that looks like this, where we're adding numbers that have decimals. And the thing they're trying to remind us of here is to line up the decimal point. So you're going to be looking at these and you're going to be saying to yourself, which one of these is written correctly? Well, this is not written correctly because the decimal point is here and here. This one wasn't written correctly because the decimal point was here and here. So they crossed those out. And then they did the problem where the decimal point was lined up correctly. Okay, so you're going to look at the next problem, decide which one is written correctly, and that's the problem you're going to solve. Okay, so that's how that page works. This next page, you're just taking the numbers themselves and you're lining up the problem. Okay, so for example, if they give you the number 2 and 75/100 plus 332 and 5/10, you need to know that you're going to write your number like this, 2 and 75/100 plus 32 and 5/10, where this decimal point is lined up. When you add and subtract decimals, the decimal point must be lined up. You need to be adding hundreds with hundreds, tenths with tenths, okay? Ones with ones, and tens with tens, okay? And you bring the decimal point straight down so everything ends up in the right place. On the back side of that same page is going into fractions, so maybe we'll save that for a different conversation. But for today, for this particular video, I want you to remember how to round and how to line up your decimal points. Okay? Thank you, and we'll see you again.